Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is minimum operations to make array continuous. So the challenge statement goes like this. You are given an integer array nums. In one operation, you can replace any element in nums with any integer. Nums is considered continuous if both of the following conditions are fulfilled. Uh, all the elements in the nums are unique, and the difference between the maximum element and the minimum element in nums is equal to nums length minus 1. So for example, let's say this is the array given to you 4 2 5 3. It is contiguous, but the following array 1 2 3 5 6 is not contiguous. Since the difference between the maximum and the minimum element in this particular array is minimum element is 2 and maximum element here is 5. Okay, so this particular array is contiguous since the maximum and minimum difference is nothing but the length minus 1, which is 3. Okay, and in this particular array, first condition is satisfied that all the elements are unique, but the minimum and maximum elements are differing by more than length minus 1, which is 1 2 3 4 5. 5 minus 1 will be 4, so 1 minus 6 will be 5. Okay, and you have to return the minimum number of operations you need to make the array continuous. So let's try to solve this problem. Let's have a look at the constraints. So the length of the array will be of order 10 raised to power 5, and the elements will be ranging from 1 to 10 raised to power 9. Okay, and let's see how we will be solving the problem. So a brute force way will be discussed first, brute force approach. Let's say, first of all, the first condition, for to satisfy the first condition, what we have to do is we have to remove all the duplicate elements in the given array. Remove duplicates in array. You can easily do with a hash set. Okay, it will always contain the unique elements. The second part of this approach will be, let's say this is the array given to you. You will consider every element as the starting point of your subarray that is contiguous. A subarray is an array that is a contiguous part of our array. Okay, and let's say this subarray is contiguous. So every index will be considered as the starting point of the subarray that is contiguous, and to check how many operations we are required to make to completely make this array contiguous array will be uh, length of this contiguous subarray minus number of elements. Let's say we denote it by small n. Small n here is the length of, or say we denote it by len. Okay, length of given nums array. Okay, this will be your n. So the number of operations required if this particular contiguous subarray is considered will be len minus contiguous subarray length. This will be the brute force approach. The time complexity will be O of n square, since we are considering every index as the starting point. This will be the starting point of the contiguous subarray. Every index will be considered this. How we can improve this brute force? Since order of n square in order of n square complexity, the number of operations that will be required is the maximum size was 10 raised to power 5, and if you square it, it will be 10 raised to power 10 operations. This will be the number of order of number of operations that your solution will be requiring. Since it is greater than the limit of 10 raised to power 8 operations, so this is a limit if the number of operations of your program exceeds or become equal to 10 raised to power 8 operations, number of operations of solution exceeds or become equal to it, then you may get a TLE and your solution will not be accepted. Okay, and those of you who are new to this concept, I will be providing a link or describing how the time complexity of accepted solution varies according to input size. Okay, then we have to do some optimizations here. What will be the optimization? Since this particular step is necessary, it cannot be removed. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the approach. So we cannot optimize here, but we can do optimizations here. How we will be doing the optimizations? What we will do is for the second part we will be doing the optimization. We will be using sorting plus sliding window. Why sliding window I will tell you, and why sorting. Sorting will be making the work of checking the difference between minimum and maximum element in a subarray of one operation. Okay, let's say this is the array given to you, and your subarray that is contiguous as of now is let's say between these two indices. Okay, and so the number of operations that will be required will be count of these elements. Okay, and if you check the minimum and maximum elements, if you want to check, then it will be the difference of nums of index 2 minus nums of index 1. Okay, this will be the difference of minimum and maximum element indeed. So that's how you will be checking for the contiguous subarray. Since all the elements in this array are already unique, we have made them unique in the first step itself, so it will help us to keep a quick check of whether the array is contiguous or not. And if, let's say, this is a particular array and this is a particular element just right after the contiguous part of the array, then we can easily shift our Windows starting point next time to this particular element and check for uh, the another contiguous array that will be existing. So sliding window will help us in that to do a to consider all the contiguous subarrays in a single traversal. To consider all continuous subarrays in single traversal. So O of n square requirement will be eliminated here, and the overall time complexity will be len length len here is the length of the nums array, okay, into log of n, log of len. Okay, this will be the time complexity required to do sorting, and sliding window approach will only be requiring O of n time. Space complexity wise, you will be only requiring order of one extra space since you are not using any extra space. So without further delay, let's try to implement the solution. So first of all, you will be required to remove the duplicate elements. It can be easily done with the help of a hash set. Let's call this unique elements. And let's insert the values of the nums array. Okay, and they are inserted. So the hash set currently is having the unique elements, and let's say you decide to store those unique elements in, let's say, let's use some extra space. So the space complexity will be O of n. Here we are declaring a new vector to store elements. Okay, and since vector uniques, so what you will be doing is you will be traversing your original array which is nums, and let's say if the current element is in unique elements, or we could have made this unique vector along with this traversal. What we can do is, let's say unique elements dot find nums, if this particular number is not there in the unique elements, then we will add it into our unique vector. Okay, now it's added, and along with that we will also add it in unique elements as set. Okay, now the second step, sorting the unique vector or say array. This will help us to find the difference between maximum and minimum elements in O of 1. Find the difference between maximum and minimum elements in order of 1 time complexity. Okay, let's sort the unique vectors array, unique vectors, uniques dot begin, uniques dot end. Okay, now it's sorted in ascending order, and another part will be to use sliding window. To find all the continuous subarrays in one traversal. Okay, so let's define the ending index, end index. It will be your end index of, or let's say this will be the index pointing to the first element that will be just next to the end of current continuous array. Okay, each index will be considered your start index basically. So nums dot size and start index, each index will be considered your starting index. Okay, so considering each index as your starting index, and then we will be forming the current contiguous array. Or continuous, you can say, subarray. Okay, and till the ending index is reaching your end of the nums array, and we are satisfying the minimum and maximum difference condition, minimum and maximum elements difference condition, which will be nothing but nums of end index minus nums of start index should be, what's the condition here? The difference should be equal to nums of length minus 1. Okay, and let's say, let's replace this. We are replacing this with sz, and we are declaring a variable size here. Okay, and it will be equal to less than or equal to sz minus 1. Then till then you will do index plus plus and index plus plus. Okay, and what will be the new operations that will be required to achieve this contiguous array? And we will be keeping a variable minimum operations. Initially, we are storing maximum integer value. So operations that will be required will be your length of whole array minus length of your current contiguous array, which will be end index minus start index. Okay, and then we will update minimum operations. Minops will be minimum of minops, and this value operations required, or you can name is camel casing. Okay, and at last we will return minimum operation. I think it should be fine. Let's try to submit for the sample test cases before submitting it for evaluation. Yeah, as you can see, for sample test cases, it's giving correct results at least. Let's try to submit for all of the test cases. As you can see, I think it's getting accepted, or wrong answer is there for this particular input. let's see what we are doing wrong here. Okay, we were doing two mistakes here. First, we were doing operations on the nums array instead of this Unix array. Okay, so the size that we were taking was of nums array, and we were doing these operations on nums array. I have replaced it with the Unix array. Another mistake that we were doing is, instead of storing the unique elements, we were storing duplicates. The condition was something like this. So it should be this. So the unique elements should be considered. Let's try to submit it for the case 4. Case 4 is the case that was giving us wrong answer. So now it's giving correct answer. As you can see, this particular one is just a debugging statement to check whether we were getting uniques or not. We can discard it now. Okay, and rest all I think is fine. Let's try to submit it again for the sample test cases. As you can see, it's getting accepted for the sample test cases. Let's try to submit. As you can see, I think it's getting accepted. Okay, so if you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. So again, I will be giving a recap. What we have done here is, first of all, we have made all the elements unique. Okay, and then we have done sorting to find the difference between maximum minimum elements in order of one-time complexity. Then we use sliding window to find all the continuous subarrays in one traversal. And let's say this particular array is contiguous, so the number of deletions number of changes that will be required is this part, number of elements in this part. Okay, for each contiguous for each index, we are considering it as the starting point of the current contiguous array, and for each contiguous array we are calculating these operations required, which is this, and minimum operations will be updated along the traversal, and at last you will be returning the minimum operations. So that's pretty much it from my side. If you are still having any doubts, again I will mention that please ask them in the comment section. So the code will be available to you in C++, Java and Python 3. So thank you for watching. Thanks.